Now we are going to say the topic is types of spectrum. Okay. So first thing is spectrum. Spectrum means colors. So spectrum means what? Colors. Okay. Now you consider a flame. So when you see this flame, it shows different colors, right? Which means the color of the flame will be changing. It depends on the temperature only. Okay. So for the initial stage, when the object becomes hot means it glows red in color. Okay. So again when the temperature is changing, which means it can be increasing again, at that time the flame glows reddish orange in color. Reddish orange. At the final stage, which means once the object becomes hottest, it glows what? Which means it is transparent. So we are telling it is white in color. So when the color of the flame is depends on the temperature. Okay. Suppose when we allow a beam of white light is allowed to pass through a prism, it's split into 7 constraint colors. So there's a light, there's a white light, is allowed to pass through a prism. It's split into 7 constraint colors. Okay. That is known as dispersion of light. That is known as what? Dispersion of light. So it's split into 7 constant colors, I said. Okay. That color is nothing but Vibgyor colors. That is rainbow colors. Okay. After the dispersion of light, the pattern of colors is obtained on the screen. That is known as spectrum. Okay. So the spectrum is classified into 2 types. One is a emission spectrum. Another one is a absorption spectrum. Okay. So what is the emission spectrum? Emission spectrum means what? Something is going to be emitted here, right? So emission spectrum. When a light is emitted directly from the source, it is examined by a spectrometer, then the emission spectrum is obtained. Okay. So here I consider a light here. Here I consider a light. And this light source is direct, and this light is directly comes from the source, right? And it is examined by a spectrometer, then the emission spectrum is obtained. That is, it can emitting all the colors. Here it emits all the colors directly from the source. Okay, that is nothing but emission spectrum. Okay, so in this spectrum, each source has its own characteristics emission spectrum. Okay, so this emission spectrum is broadly classified into 3 types. One is a continuous emission spectrum, and second one is a line emission spectrum, and third one is a band emission spectrum. So the emission spectrum it is of 3 types. One is a continuous emission spectrum, and second one is line emission spectrum, and third one is band emission spectrum. Okay, so the first one is continuous emission spectrum. So what is a continuous emission spectrum? We'll see now. Continuous emission spectrum. Okay. Now we consider a incandescent bulb. That is a filament bulb here. So in this bulb, a light source is directly passing through the prism. Okay. Now it's split into what? 7 colors. That is a Vibgyor colors. It ranges from violet to red. Okay. Once a light source is passing through the prism, it continuously emitting all the colors. That is a continuous emission spectrum. Okay. And the example of continuous emission spectrum is spectrum obtained from carbon arc and incandescent solids and liquids. And spectrum obtained from liquids, it gives what? Continuous spectrum. This is nothing but continuous emission spectrum. Okay. And the second one is line emission spectrum. So line emission spectrum means what? Here for continuous emission spectrum, we took a light, right? So instead of light, here I am going to consider a gas. Okay. So this gas is either a helium gas or a hydrogen gas. Okay. Now what I am going to do, I am going to heat this gas. So that is a hot gas. So while heating this gas, the atoms and molecules are getting excited so that it creates a light source. It creates what? Light source. Okay. So that light source is passing through a prism and that is emitting a line emission spectrum. So the spectrum could be like this. This is a line emission spectrum. So these sharp lines should have the definite frequency or wavelength. Okay, this is nothing but line emission spectrum. And the third one is band emission spectrum. So what is the band emission spectrum? So band is nothing but it is not the single line. Okay, so each band is made up of large number of spectral lines which are closely spaced, which means we are very close to each other and separated by a dark spaces. It is called what? Band spectra. Okay, so this band spectrum is obtained from molecules only. So the band is nothing but large number of spectral lines which are very close to each other. So the band spectrum is obtained. Okay, so in this band spectrum, here the sharp edge is at one end and fades out at the end. Okay, so the example of band emission spectra, that is for what? Even a discharge tube, ammonia gas, and all emitting band emission spectrum only. Okay, so by using this band emission spectrum, we can able to study the structure of molecules. This is nothing but band emission spectrum. Okay, and the second type of spectrum is absorption spectrum, right? So first one is emission spectra and second one is what? Absorption spectra. So what do you mean by absorption spectra? In emission spectra I said then the light is emitted directly from the source, right? But here the light is emitted from the source, it is made to pass through a absorbing material, then it is examined by a spectrometer, that is called absorption spectra, which means there is a white light, it is allowed to pass through a absorbing material. So any absorbing material, right? And then is allowed to pass through a prism. Absorption spectrum is obtained. Okay, so this light is allowed to pass through absorbing material and then is allowed to pass through a prism, then the absorption spectrum is obtained. Okay, so this absorption spectrum is classified into three types. The one is continuous absorption spectrum and second one is line absorption spectrum and the third one is band absorption spectrum. So we'll see one by one. The first one is continuous absorption spectrum. So what is a continuous absorption spectrum? So here I consider a white light here. Okay, then it is allowed to pass through a absorbing material that I consider here. It is a green glass plate. So when the light is allowed to pass through a green glass plate, so this plate can absorb all the colors except green. Okay, so and then is allowed to pass through a prism. It emits only what is that? Green color light, which means it absorbs all the colors except green. That is a continuous absorption spectrum because it is continuously absorbs all the colors except this green. Okay, this is nothing but continuous absorption spectrum. Okay, and the second one is line absorption spectrum. So what is a line absorption spectrum? When the light from the incandescent bulb or lamp like that, okay, it is allowed to pass through a medium. So medium here considered as a cold gas. Okay, then the spectrum is obtained on the dispersion due to prism. That is called what? Line absorption spectrum, which means that here the light, right? So the light from the carbon arc, it is allowed to pass through a medium. That medium I consider what is that? Sodium vapor. Sodium vapor. Okay, and then it's allowed to pass through a prism. It obtained a carbon arc of 2 yellow region of sodium vapor. Okay, that is nothing but line absorption spectrum, right? So these 2 yellow regions of sodium vapor and the wavelength ranges 5896 angstrom to 5890 angstrom. Okay, this is nothing but line absorption spectrum. Okay, and the third one is band absorption spectrum. So what do you mean by band absorption spectrum? So band absorption spectrum is nothing but when a light from the source is passed through a iodine vapor, dark bands on continuous bright background is obtained. This type of band is also called what? Band absorption spectrum. And the example is hair dye. Okay, so hair dye is an example of what? Band absorption spectrum. Okay, and the last one is what? Fraunhofer lines. So what do you mean by Fraunhofer lines? Fraunhofer lines means what? The main source of Fraunhofer line is sun. Okay, so when the spectrum obtained from the sun, it consists of large number of dark lines. Okay, so these dark lines in the solar spectrum are known as what? Fraunhofer lines only. Okay, so by using this Fraunhofer lines, which helps to identify what are the elements which are present in the sun's atmosphere. That is nothing but what? Fraunhofer lines is a very important 2-mark question. Which means when the spectrum is obtained from the sun, it consists of large number of dark lines in the solar spectrum. That is called as what? Fraunhofer lines. That's it.